This is 5.1, Part 5. We're just going to go over a brief summary of what we've seen in the 4 videos for 5.1. So what we saw was the stretching and reflecting of quadratic relations. We saw that if a was larger than 1 in the relation y is equal to ax squared, what that means is that we have a vertical stretching of the parabola y is equal to x squared, meaning that it's rising faster. If we have a is less than 1, but still positive, so still more than 0, then we have a vertical compression. So what I want you to get is, let's say for example we had y is equal to x squared and y is equal to 3x squared. Y is equal to 3x squared would be a vertical stretching of y is equal to x squared. It goes up 3 times faster. They still have the same vertex, so it's stretched from the vertex. If we had y is equal to 0.5 x squared, this would be a vertical compression, so it wouldn't rise as fast. For the stretching, the parabola looks narrower because it's going up faster. For the compression, the parabola looks wider because it's going up more slowly. And let's say that x squared is kind of somewhere in between these ones here. So that is what happens when you put an a that's larger than 1 or an a that's smaller than 1 but still positive. Now as soon as you make your a negative, so let's say you have an a that's less than 0, for example y is equal to negative x squared, where a is negative 1 in this case, we have a reflection. The parabola flips. It no longer opens from the top if it was positive before. Now it opens from the bottom. So if we had y is equal to negative x squared, let's say this over here is y is equal to x squared, y is equal to negative x squared would be the essentially very similar parabola, just flipped about the x-axis. And so those were the main transformations that we saw with regards to the a larger than 1 stretches vertically from the vertex, a smaller than 1 still positive compresses vertically from the vertex, and then a less than 0, so negative, meaning a reflection. And you can combine these two. So you could have, for example, y is equal to negative 3x squared. So you have a reflection accounted for by the negative, and also a stretching accounted for by the a value there, that 3 that's larger than 1. And then likewise you could have a is equal to negative 0.5, so 0.5 x squared. So we have a compression caused by this little a value here, not looking at the sign, being less than 1, and then a reflection caused by that sign, that negative sign there, about the x-axis. And we used our mapping rule in order to take the graph of y is equal to x squared and convert it into another type of graph with a modification to the a. So we saw the example of y is equal to 4x squared and y is equal to negative 0.5 squared. So that's a summary of this lesson. We will be seeing other transformations in this unit, so please make sure you review this transformation very carefully, and you can do proper graphing based on the transformation rules that we discussed today.